Okay, so are there any questions over the conjunction? And let me say before you ask anything, most of the time you won't have to worry about what this word means, conjunction. If you just remember the and statement, then you'll be set almost all the time. But are there any questions? So let's move on to the second kind of connective called the disjunction. So you might think of it as the opposite of the conjunction. And this is the or statement. And since we think of this kind of as the opposite of the and statement, we flip the symbol for and, the upside down V becomes a right side up V for the or statement. So if you were reading off the statement, you would just say P or Q. Okay. So we have to be a bit careful with the definition of the or statement because it might be a little bit different than the way that you think of or normally being, like when you're speaking. And what it means in logic and what a computer understands or to mean is that at least one of these two statements is true. Right, so Caden, it is the inclusive or. So often when we're just speaking, when we say or, we mean either or. So either this or that, and that would be the exclusive or, where you're saying only one of the two is true. But in this case, you can have either one be true, or even both. Okay, so what's a good example? Just picking some that we've already used, we could have Tulsa is the capital of Oklahoma as our first statement. That one's false, remember. Or 2 plus 2 equals 4. So we have one false statement, one true statement. So that means at least one of them is true. So this is good. Yeah, it's true overall. Okay, or we could have both of them true. I could have said, what did I say earlier? The sky is blue. Or 1 plus 5 equals 6. So now we have two true statements. And since we're using the inclusive or, that means this is a true statement overall. Okay, any questions over the disjunction before we move on? Okay, so before we get to the third kind of logical connective, we need to talk about truth tables. And truth tables are a way to look at the truth value of a complex statement. Maybe let's say the possible truth values. And I'll just explain really quick how they work. Once you've seen how they work, they won't be too much of a mystery. Over on this side, in this little section, we're going to put propositions. So these are things that can be true or false. And on this side, on the upper right, we're going to put a more complicated compounds. Yes, Davian says these are confusing when the proposition gets longer. Right, and that's true. And this is the truth table lets us break it down into easier to understand pieces. So a more complicated kind of thing, we could have P or Q, and then it could get more complicated. Like here's another symbol that we haven't seen. This one is an implication. Maybe I have R and Q over here. So this is a complicated thing. You don't even know one of the symbols yet. We'll get there. But a truth table is going to let us break it down. And let me fill in, since I have 1, 2, 3 different simple statements or simple propositions over here, on this left side, I would fill in P, Q, and R. And underneath these letters that are standing for my propositions, I'm going to write all of the possible truth values. So what I mean by that is that P and Q and R could be true or false, and the combination of which ones are true and which ones are false can change. So I might start by saying they could all be true, and then when all of them are true, I would try to figure out if this statement is true or false. We're not going to worry about that right now. That's for a little bit later. Okay, but there's more possibilities. Like I could have P true, Q true, and then R could be false. So instead of a T for true, I'll write an F for false. Okay, and then let me fill in the rest of them. We could have Q false and the rest of them true, or we could have P false and the rest true. Right, it has all of the possible combinations. That's right, Davian. Okay, so I have 1 false, 2 true on these 3 lines, and I could have 2 false propositions. I could have a true, false, false. I could have a false, true, false. Or I could have a false, false, true. And unfortunately, I put that in a bad spot. But there is one more to add. I could have 3 false statements. I could have a false, false, and a false. Okay. So you're going to be getting some practice making these truth tables. But what I would recommend when you actually start making them on your own is to fill in this area the same way every time that you do it. It's just a little bit of advice that should help you get the correct answer. Okay, so for example, the way that I think about these is that I start with everything true, and then I go through all of the 3 possibilities for there being 1 false, and then there's 3 possibilities for 2 falses, And then there's the last one where everything is false. So overall, I have 8 possibilities. And that number of possibilities is going to depend on the number of simple propositions that you have up here.
You said try to do it the same way every time. If there's like a different way that feels more comfortable, is that okay?
Yeah, that's totally fine. Yeah, everyone has their own preferred way of doing things. I explained the way that I think about it, but if you want to do it differently, that's totally fine as well. 2 to the n minus 1. You're very close. It's just 2 to the n, where n is the number of propositions. So there's 2 possibilities for each statement. So you're multiplying 2 times 2 times 2 in this case to get 8 total possibilities. Any questions before we move on? I'll write out an example in just a second. Okay. So what I want to do is fill out a truth table for the 2 logical connectives that we've learned, the and statement and the or statement, or to be consistent, the and proposition. So this time I have 2 simple statements, 2 simple propositions that I'm combining together with the and. So when I have 2 simple propositions, that means I'm going to have 2 times 2, or 4 possibilities. So I filled in one already. We could also have a true and a false, or a false and a true. And then the last possibility is 2 falses. Okay, so thinking back to what the and statement means, the and is true when both simple propositions are true. And that corresponds to the first line. But when either of the other 2 are false, so either of these three lines, and then there's a question, will the P or Q ever be statements that we have to write out, or always variables? So when you're making a truth table, like I'm doing here, you're going to want to use letters or variables all the time. If you tried to write out sentences, well, it would just take up way too much room. So try to avoid doing that. Okay, so when either of these 2 simple propositions is false, that means the and, when you're combining them, is false overall. So that means the rest of the rows I'll fill in here with an F. So over here we have the truth values of the simple propositions, and on the right side we have the truth value of the more complicated proposition. And this is what you're going to be doing whenever you make a truth table on your own. I guess I should see if there are questions about that one. Any questions? Okay. So let's do the truth table for the or proposition. Disjunction. And as I said earlier, you should try to fill in the left the same way every time you do it. So I'm going to fill it in with true, 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 false, false, true, and then the last possibility, false, false. So it looks exactly the same on the left side as the other truth table. But now on the right column, we have to fill in the truth value for the or proposition. And we know that this one is true if at least one of the simple propositions, the P or the Q, are true. So that corresponds to the first 3 rows. We have 2 trues and then 1 true in these 2. So we get true, true, true in this column. And then the last column where we have 2 falses, the or proposition is false. Okay, so, right, because only one has to be true. So here we have 2, 1, and 1 trues, and then 0 trues. Yes, for the and statement, both have to be true. So that's why only the first line gives us a true in this truth table. Will false, false ever be true? So you're asking if this row could ever correspond to a true in the more complicated column. And yes, sometimes it could be. I don't have an example for us today, not with 2 statements, but maybe this last example with 1 statement will give you a good idea of when that might happen. So my third example is about the negation. And this is an English equivalent to the word not. So I'm saying not, and then whatever my proposition is. And then the notation that we're going to use is like this. I guess you might call this sideways L, or maybe an elbow or something. So whenever you write this little elbow symbol next to a proposition, like I've done here, it means the negation or not of whatever this is. And it works exactly like not does in English. If you write not next to something, that means you're changing the truth value of it. The negation of a proposition has the opposite truth value. So if you say not the sky is blue, it's not really maybe grammatically correct, but you're saying this is false. That's what you're asserting. So on a truth table, since this only involves one simple proposition, there's only 2 possibilities for a left column. The simple statement P can be true or false, and those are the only possibilities. And when we add the negation, so we say not P, we just switch these. So a true becomes false, and a false becomes true. So this last row is maybe a good example of when you can have something that's totally false on the left, but your more complicated logical statement becomes true. And this one is just a negation, but there will be examples where you have more than one on the left side. Okay, are there any questions? Okay, so no one is saying anything. And in the last couple minutes of class, I want to show you maybe how this could work in a programming context. Um, so I just shared my screen with you, and this is a Jupyter notebook running Python. Maybe you've had some experience with Python, but it works pretty close to lots of other languages. It's a bit simpler, but I can do logic kinds of things in here. So I could say a statement P is true, and I could say a statement Q is true. So I have variables and they have truth values. So if I wrote P, it would tell me P is true. If I wrote Q, it would tell me Q is true. And we can also combine them using logical statements like P, and then Python is really simple. I can just write and Q. And it tells me that P and Q is true because both of them are true. But if I go back up to the top and maybe I change Q to be false, and then I check P and Q again, it'll tell me that the overall statement is false because both aren't true. I can do the same thing with the or. P or Q is true because at least one of them is true. And we also have a not statement. So not P will be true. Sorry, not P is false because it was true. And then not Q is true because true started as false. Okay, and I think we'll stop there. I just wanted to show you really quick as an example that these kinds of statements, these logical connectives and this sort of thing, it really does have a programming use. You'll use these kinds of things all the time whenever you're programming. Okay, so any questions? Okay, so let's just stop there.